Alright guys, how's this going? So today we're going to be solving the first Leet Code on this channel. We're doing two-sum. It's probably one of the most infamous Leet Codes. I know it's a place where a lot of people start, and it's a lot of times the first one they will solve. And honestly, it's a pretty fun one. So today we're going to be coding in C++. It's a language that I tend to use the most comfortable in. If you see the code in C++ and you program primarily in a different language, it's not too hard to switch it over at all. So I'll leave that up to you guys if you want to do it, but let's get started. So the first thing to note is that when looking at the code, this function returns a vector. So I'm going to make a note of that right off the bat. The other thing to look at is that we're being passed in a vector of integers and an integer called target. So now when we come here, we see that given an array of integers, nums, and the integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So if we look at the first example, we see that the input is a vector of numbers, and the numbers are 2, 7, 11, 15. The target is 9. Obviously, looking at this, we can say, okay, 2 plus 7 equals 9. But the question is, how do we get the program to return the indices of those two numbers in a case where maybe we have 1,000 numbers inside the vector, or, you know, a much bigger target? So I think when you're looking at this and you also see that it says you may not use the same element twice, that's a big hint to you that you're going to have two things looping through this vector. And obviously that's going to be a for loop, so we're going to start with for int x equals 0, I is less than nums.size, because we want to go to the end of the vector, and we're going to I++, we're going to increment our I value. Now, one thing about the dot size function, if you guys aren't familiar, in C++, dot size returns the number of items inside of a data structure, specifically vectors, I believe. So when I do dot size on this, for example, I'm going to get a value of 4. However, the index, it only goes from 0, 1, 2 to 3. So whenever I use a dot size function, you're almost always going to have to do -1. Now, let's do our second of the nested statements. We're going to do for int z. Actually, I'll do j. For int j equals. Now, remember how the problem said we may not use the same element twice? That means if we start this as 0, there's going to be a point where we're looking at 0 and 0. So what we can do to always keep this 1 ahead is we can just do for int j equals x plus 1. And again, we're going to run to the end, but this time we don't have to do the -1, because we're already being pushed 1 ahead of the x loop, the x counter. And then we'll just do j plus plus, close that off. So if we got to this point, that means that now we have to check for the condition to see if they equal a target. That's a matter of a simple if statement. We're going to do if, and there's two ways to check a certain value of the indice of a vector. I primarily like to use I believe they're called square brackets. So if nums I, and I can barely see because of how the screen is, but if nums I plus nums j equals target, and that equals is checking to see if it's equals, then we'll carry out an operation here. Now, one thing about C++ is that it can be a little weird with how it interprets mathematical statements, and I'm not an expert on this by any means, but there's been times where this will work, and there's also times when it'll take it as nums I plus this right here, and this is going to return a Boolean value. So just to make sure that it's checking to see if that integer is equal to the integer of target, we're going to put parentheses around it, so it does that operation first. So at this point, if we got in here in the code, we found our answer. Keep in mind that this function returns a vector, so I'm going to initialize an empty vector of type int, because this returns a vector of type int called sol. And if I got here, my x value and my j value should hold the indices of the two solutions. So we're just going to do sol.push back, and the way pushback works is you put the vector first, or the destination, and then you do dot pushback, and then inside of the parentheses you're going to put what you want to push in. It said you can return the answer in any order, but we're going to do I first and then j. and then we'll do sol.push back j. And now we can return sol. And that's our answer. Now, one funny thing that's going to happen with C++ is that right here, this is where all the code inside my last for loop terminates, right? If for some reason you have a case where it obviously can't happen here because only one valid answer exists, but this return here is not enough. C++ is going to look at this and it's going to say, hey, what if this if statement is never true? Then I have no way to return out of this function, causing an error. So just to be safe, we're going to return sol right here. And let's give it a test. What did I do wrong? For int x equals 0, because for some reason I typed int x here. That should be int I equals 0. And I did it here as well. I'm not sure why I did that. No, go away. Go away. Alright. Oh my goodness, I cannot type tonight. Well, I apologize for all those errors, but there we go. As you can see, the code works, and I will submit it to be run through all the test cases. And there we go. And ignore these are just older, you're messing around, but it's a pretty fast answer. It's probably not the best way to do it. I'm sure there's better ways to do it, but yeah. Alright, that's all for tonight. Hope you guys have a good night, and hopefully you enjoyed.